Good evening, everyone. This is Mrs. Wilson, and tonight I'm going to show you how to write polynomials given roots. This comes from section 6.5 in your book. It's kind of a continuation of what we were doing yesterday. Remember that you can stop this video at any time if you need to go back, and feel free to rewind. Or if you already know what I'm doing, you can skip through some of the various examples that I will give. So what we're going to look at today is if I give you the roots or the places where a polynomial crosses the x-axis, or in the case of complex roots, it'll be up within one of the quadrants. Can you write a polynomial function based on those? So we're going to dive right in with one example. This is example number 1. And you are given the roots of -2, 1, and 4. So we have 3 roots. We know then that we should end up with an x cubed, or a cubic polynomial as a result. So what we're going to do is just change these roots into factors and then multiply our factors together. After we simplify, we should have a cubic polynomial. So I'm going to start by writing each of my roots as an x equals. Then I'm going to set each of these equal to 0. And now I have 3 factors. That, when multiplied together, are going to give me my polynomial. So we're just going to do FOIL. You can pick any 2 to start. I'm going to start with the first 2. FOIL those out. So the first 2 we multiply. The outside terms, the inside terms, and the last 2 terms. I'm going to go ahead and bring down that other factor. We'll take care of that in a minute. I'm going to come through and simplify this. And now I'm ready to multiply again. And at the end of this example, or after the end of this, we will have our answer. Okay, so I'm going to multiply x squared times both terms in the second factor. That's going to give me x cubed minus 4x squared. Then I'm going to move on to x and do the same. Gets multiplied by both terms in the second factor. And finally, my -2 multiplied by both terms. After this, we can combine like terms. I've got a couple x squared there. I've got some x's and my constant. That is our answer. This is a polynomial that had the original roots of -2, 1, and 4. Okay, and just notice that we started with 3 roots, -2, 1, and 4, and we ended with an x cubed. So whatever you start with, that is a clue as to what the degree of your polynomial should be. It's a good checking point for you. Okay, let's do another example. This is example number 2. This time, the roots that I'm going to give you are a little bit different. We're going to start with 2, and we're also going to give you 3i. So we have both a real root and one complex root. That I is the imaginary component. The key to this is, even though I've only given you 2 roots, you need to remember that complex roots always come in pairs. So even though I've only given you 3i, we also know that -3i is a root as well. That's an implied root. Alright, so be careful. When you see one of those i's, make sure it has its conjugate with it. Alright, its pair. Okay, so even before I'm going to anticipating ending up with a cubic polynomial. I have 3 given roots. I should end up with an x cubed when I'm done with this. We're going to use the same process as before, which is turn the roots into factors. Okay? And we do this by setting them each equal to 0. And now I have my factors. And I'm ready to begin multiplying. All right, I'm going to start with these two this time, and that's because those are conjugates of each other. When you multiply conjugates, or binomials where you have a negative and a positive sign, you're adding and subtracting that second term, we know we can kind of cheat the FOIL process a little bit because our outside and inside products are automatically going to cancel out. That's the beauty of working with conjugates. So by working with these two first, I'm going to be able to get rid of those i's. All right, so I'm going to FOIL these two. First two terms is x squared. Outside terms is plus 3ix. Inside terms is minus 3ix. See, those are going to cancel out. And then in the end, I have negative 9i squared. So when I come through and simplify this, my imaginary numbers cancel out. Remember that I squared is really negative 1. So this becomes a plus 9. Now I'm ready to FOIL again. All right. So first two terms, that gives us our x cubed. Our outside terms is plus 9x. Inside terms and last terms. Once we simplify, we will have our polynomial. And in this case, I don't have any like terms, so I'm just going to reorder this in descending degree. And there is our finished polynomial. Okay, on to our third example. This is the last example we're going to do. It's a little more challenging because you'll notice that I've given you as one of your roots a binomial. Okay, previously I've just been giving you constants or imaginary numbers, but now we've got a complex binomial. So just like before with complex roots, we're going to go ahead and include its conjugate. All right, so this is not a quadratic. This is going to be a cubic like the other ones. This one's a little more challenging given the nature of these roots because we have two binomials as roots. And so you'll see how this one, we add another feature when we're working it. So first step is the same. We want to write these as equations. Then we're going to set each equal to 0. And notice with those complex roots, I am subtracting the entire binomial. All right, so make sure that you do that. Okay? Here's one of our factors. Over here, one of our factors then becomes x minus 3 plus I. And the third factor, x minus 3 minus I, distributed the negative sign. All right. Now, it is possible for you to go ahead and multiply all three of those roots together like we've been doing. However, you're not using FOIL on these two because these are two trinomials. So it can get a little dicey here, lots of room for error. So rather than multiplying those together, we're going to go back to last semester when we learned about the product and sum rules. So kind of forgetting about this x plus 2 for now. We're just going to focus on coming up with a quadratic that has these as its two roots. And then once we have that, we'll go ahead and multiply the x plus 2. So we're going to go back to our sum and product rules, which says that if you add two roots together, you will end up with the ratio of negative b over a. And the product rule, which says if you multiply two roots together, you will end up with the ratio of c over a. A, b, and c relate to our quadratic equation in standard form. So what we're doing is we are coming up with the numbers that fill in those coefficient places, a, b, and c. Okay, so I'm going to go back up to the original roots 3 minus I, and 3 plus I, and that's what I'm going to add together and multiply. So we'll start with the sum. When I add the two together, 3 minus I plus 3 plus I end up with 6, and then my i's add up to 0. So they kind of cancel each other out. We can also write this as 6 over 1. And remember that relates to the ratio negative b over a. To find c, we want to multiply the two together. These are conjugates. The beauty of conjugates, again, is that we can kind of cheat that FOIL process. I know the outside and the inside terms are going to cancel out. So all I really need to multiply are the first two terms and the last two terms. I squared is really a negative 1, so this becomes 9 plus 1, which equals 10. And that is in the ratio of c over a. So multiplying these two together is going to give me ax squared, in this case a is 1, plus bx, my b in this case, negative b was 6, so positive b will be negative 6, plus c, and c we can see right here is 10. Okay, so this is the product of these two factors. To get my finished polynomial, all I have to do is multiply this by that x plus 2. So I'm bringing down that x plus 2. Can't forget about it. That's what's going to give me the cubic. And I knew I was going to have a cubic because I started with 3 roots. So now we're back to just multiplying. I'm going to multiply the x times every term in my trinomial. That'll give me x cubed minus 6x squared plus 10x. And then I'm going to multiply the 2 times every term. Plus 2x squared minus 12x plus 20. Let's go and combine like terms. I have an x cubed. There are my x squareds. Here are my x's. And finally my 20. And there you have it. There's your polynomial based on the given roots of negative 2 and 3 minus I.